Hi everybody, and welcome to topic 4, solving equations with variables on each side. So if you look at the 3 bullets at the top, it gives you pointers of what to do when you have an equation that has variable on both sides. So if we look at the first example, you're going to see that we have a 2x on the left and an x on the right. So this is set up a little bit differently than what we're used to seeing. So what we have to do is get the variables on one side by using the opposite operation. We've talked about that for all these units or topics so far. So we have to use the opposite operation to get both of those variables just on one side. So if we look at number 1, I need to get my 2x and my x on the same side. So because I have a positive x, I'm going to add that little plus sign so we can see that it is a positive. In order to do the opposite operation, it is subtraction. So whatever I do to one side, I have to do to the other. Once I do that, I get 2x minus x, which is x. I have my plus 1. The positive x and the negative x cancel, and I just get 11. So I moved my variables from the right to the left side. So now what I need to do, if we look at bullet number 2, is get all the numbers on the other side by using the opposite operation. So my variables are on the left, so I need my regular numbers on the right. So the opposite operation here would be to subtract 1 from both sides. That way I get rid of my 1 on the left, so x is finally by itself, and 11 minus 1 gives me 10. Let's try it for that second example. Up here. So we have a 5a on the left and an 8a on the right, a negative 3 on the left, and a positive 6 on the right. So the first thing we need to do, that first bullet, is to get the variables on one side. So what I would like to do is I like to keep my variables positive, so I always move the smaller variable term. So 8a is bigger than 5a, so I am going to subtract 5a from both sides. Because this was a positive 5a, by subtracting it, I'll get it to cancel out. And I'm left with negative 3 equals 8 minus 5, which is 3, and my a always stays because I'm adding or subtracting. And then plus 6 is on the other side. Now if I follow bullet number 2, I need to move my numbers to the other side. So I moved my variables to the right. Now I need to move my numbers to the left. So I need to use the opposite operation once again. To move that 6, I need to undo that so that they cancel out. And I'm left with negative 3 minus 6, which is negative 9, equals 3a. From here, we are still not finished, but we're almost there. We need to get a by itself, and because 3 is being multiplied by a, I need to divide both sides by 3. When I do that, I get negative 3 equals a, and that is my final answer. Now, when we see problems that require us to distribute first, that's what we need to do. So before we can even move something, we need to get rid of those parentheses by distributing. So 2 times 6m is 12m, and 2 times negative 1 is negative 2. And that's equal to 18. In this case, we need to get the m's on one side and our regular numbers on the other side. So I am going to move my 12m. Since the negative 2, there's no other constants in that equation, I'm going to move the 12m to the right. So because it's a positive 12m, I am going to subtract 12m from both sides. The 12 and the negative 12m cancel out, and I'm left with negative 2 equals 8 minus 12, negative 4m. because I'm running out of room, I'm going to pick back up here. Sorry about that. So I have -2 equals -4m. I'm just rewriting it so I can clearly see what's going on. If -4 is being multiplied by m, the opposite operation would be to divide by -4 to get m by itself. That will cancel out, and I'm left with -2 over -4. Negative divided by a negative is a positive, so I'm left with +2 over 4. But we can reduce that to 1/2, and we need to give our answers in fully reduced form. So make sure that we reduce it. The fourth example requires us to distribute on both sides, so let's go ahead and do that. 2 times s is 2s, 11 times 2 is 22, 5 times s is 5s, and 5 times 2 is 10. So that's my first step. Now I need to get my variables on one side. So because 5 is bigger than 2, I'm going to move my 2 over. So because that was a positive 2s, I subtract 2s from both sides. Those will cancel. I'm left with 22 equals 5 minus 2 is 3s plus 10. Next, because I moved my variables to the right, I need my constants or my regular numbers on the left, so the 10 needs to move. I'm going to subtract it because that is the opposite operation of addition. 22 minus 10 is 12, and that's equal to 3s, and the 10 and the -10 cancel out. Last but not least, 3 is being multiplied by s, so I need to divide by 3, and whatever I do to one side, I do to the other. 12 divided by 3 is 4, and those 3's will cancel, so I get 4 is equal to s. So we have some special cases that are in these two examples. We're going to talk about them. Sometimes they have no solution. So when you go through, let's start by solving this equation. Let's go through and solve. We need to distribute first. That's the first thing we always need to do if we see those parentheses. And again, -2 equals 4 plus 2x. First step. So now what we do after that is we move our variables to one side. So they're both 2x, so I'm just going to subtract the one on the right. But when I subtract it from the left, because they are the same, they both cancel out, and I'm left with -2 equals 4. Now, that statement is very much false. When you get a statement that is false, the answer is no solution. So it's like a big 0 with a line through it, and that means no solution. When you get a statement that is false, -2 is not equal to -4. Never. Right, and then we have the opposite case, where sometimes every number is a solution. So the set is going to be all real numbers. So let's go ahead and start this problem by distributing. -2 times x is -2x. -2 times -1 is +2. Our first step is always to move our variables to one side, so I'm going to do the opposite operation. It's a -2x, so now I need to add it to both sides. When I do that, that will cancel. I'm left with +2 equals 2, and this side cancels out as well. This statement is very much true. 2 is always equal to -2. Always. So what we say is our answer is all real numbers. That means any number that you plug in for x, as long as you plug the same number in for both x's, is you will get a true statement. And we can also represent this by using a fancy R. It's just like an R with an extra little backbone or line, but this is the symbol that you can use if you're lazy like me and you don't like to write out all real numbers, because that fancy R means all real numbers. So what I want you guys to do is go through these U-tries, all 4 of them, and make sure to check your answers. And we'll see you in class tomorrow.